Hey YouTube, JP Dillon. Here's a bit of a weird one today. I was going to work on that Sears Performance Sanyo based TV and the General Electric, but then this repair came up, and I thought that you guys might want to take a look at this. This is a General Electric, about maybe 1972, 73. It's not made by GE, it's made for GE. There's a date code there. I could be wrong on that year, but I'm not good with date codes. It is a model Sc2310b, 100 watts, made in Japan. And the performance on this, according to its owner, has been really crummy. Sound's been muddy, radio sensitivity is terrible. He wants to get the 8-track working. You see we've got this thing called decoder switch. I don't know if this is supposed to be a 4-channel receiver or what, because it just says it's a stereo. The good thing about it is, 8-track wise, if we get the camera in there, the 8-track head's in pretty good shape, and it's got a metal bracket instead of a plastic one that often shows up later. So I think this definitely predates 1970, if that's the case. Because after 70 you started seeing plastic head brackets. But maybe somebody who can decode that EIA code knows better. Also, one of the meters is stuck. He doesn't really care about that. I don't think I'll be able to fix that anyways. So the next thing to do is to hook it up and see what deficiencies it really has. Alright, so here it is all hooked up. Let's just center everything here. Turn all volume down, AFC off. Alright. Let's see if I can.
Or on his way out.
Very bass heavy.
Regret.
These are the things
in deferred maintenance business.
The FM sensitivity really sucks. A lot of distortion.
Supreme Court ruled in Humphrey's favor. For a pretty good reason.
He was also complaining that the phono stage didn't work, so let's get a signal put in here. Let's see now. Phono and aux. That's standard RIAA, about maybe 20 millivolts. Sensitivity on it sucks. I'm betting it's really for a, let's do a ceramic cartridge input of about a 0.5 volt. That's what it wants. There's also some distortion there. Yeah. Shouldn't sound like that. Almost sounds like a sawtooth or a square wave. Or that might be my crummy speaker too. Let's see what the scope says. Okay, so looking at the oscilloscope, there's lots of noise, probably germanium transistor noise, but you can see here there's this notch, this beautiful notch here. That's that kind of sawtoothy thing we're hearing here. So that one channel is messed up. It's not my speaker. The other side, the left side, is clean, which is what that speaker down there was playing out of. That side's clean, but the right side, which is this channel, is no bueno. Let's see here. So if I pull that out, yeah, that's actually the right channel. The left channel was the one that's buggered. So I just had my speakers crossed. Let's see if that's frequency dependent. We do have some RIAA curve here that tells me that the phono stage is actually acting like a phono stage. It's not very much, so I'm guessing it's really looking for a ceramic cartridge. You can also see the frequency response isn't very linear in both channels. The left seems to amplify greater than the right does. And look at all that noise. Lovely transistor noise. Let's go up here. 10K. Yeah, so it's probably looking for a ceramic cartridge. I'm going to have to tell him he really needs a phono preamp because he wanted to use a magnetic cartridge with this thing. I'm not sure if he was really set up for that. Okay, so let's go to the auxiliary. And even in auxiliary, you can see it's a little bit quieter, but it's definitely still got that notch there. That notch right there, not as pronounced either. So there's something going on in that left channel amplifier. And as far as the loudness curve is concerned, we do have a, that's interesting, but below 40 it's gone, so it probably has some little piddly output capacitor there. 100 hertz, it's pretty strong, and then as we start to go up to 400 it gets smaller, so there's a built-in loudness curve. They were probably trying to mate it with whatever matching speakers there were. And as we get above kilohertz, it definitely goes down. So let's see what happens when we get to, wow, look at that distortion there. That's kind of ugly. 1K, 2, 3, 4, 5. Wow, after 5K, it's just like it's gone. That's a significant drop. And that's supposedly with the tone controls at flat. And even if I crank the treble up all the way, by 10K it still depletes. Look at that. And then we've got this awesomeness up here. Look at that. That left channel there. Horrid distortion when you manipulate the treble control. And then, alright, so let's see here. A really big slope as far as it equalizing. And let's see if we can, even with the bass turned all the way down and the treble turned all the way up, it's almost linear. Almost. And then we get this hump here at 4 to 5K. And then, again, after 10K, God, let's see here. Let's make it so you can see it. That right channel depletes quick too. That's weird. So you've got this hump here between 5 to 10K. And that's again with the controls at their extreme. That's almost linear. So this was really meant for the speakers that came with this thing. Now if we're curious, let's see what sort of mondo power it puts out. We're going to put the controls back to what they call flat. And that's not very much. Let's max this out. And you can see the right channel clips before the left. And you've got some pretty bad distortion there. It's not a pure sine, it's very rounded. And the clipping varies too. Like it clips more at a lower distortion than it does a high. So this is not hi-fi in the least. But yeah, at about a kilohertz, it's pretty rounded. That's almost like tube harmonic distortion, but I'm sure it doesn't sound very good. And that's firing into 8 ohms. Let's see if we can make that a little more linear and matching. That's about right. About the same there. Turn that up. Alright, so that's both channels at maximum output. Let's see what that is. Okay, so that's 8.33 volts AC. We want to round down to 8 to make the math easy. That's 8 squared 64 divided by 8 is 8. So, yeah, 8 watts. If that. It's 8 watts into 8 ohms. And I think they're running 16 ohm speakers on this, so I'm really actually pushing this pretty hard right now. Because I think the rear panel says 16 ohm. I could be wrong. GE likes to make stuff weird. So there's your Mondo 8 watts per channel receiver. Granted, the speakers that came with it were probably really efficient, and I know he's got some like SP1500s or something Sansui that's really efficient as well. So I'm using a small place, so it'll work. So now, really, what we need to focus on is getting this thing so that it's linear and a little more hi-fi. It doesn't have to be great. It's never going to be a great performer. If we go back to FM. Let's turn up our sensitivity here, and I've got my SoundTech 1000 cranked up there. That's my little radio station. Let's see if the oscillator is correct. We're going to tune to about 98.5. And the oscillator actually reads pretty close. And alright, so there's our radio station. The sensitivity is terrible. You can see the transient there switching between mono to stereo. Let's look at our stereo separation. And it's non-existent. Even though I can see the switching circuit kicking it from mono to stereo. Or maybe that's a muting circuit, who knows. Let's actually go to FM stereo, since I wasn't in that selection before. The switching circuit's pretty noisy, and you've got some definite separation distortion problems there. But this isn't a spiffy thing. This is your thing that you bought from GE that looks cool. It's probably made by somebody like Matsushita or JVC. We're going to pop it open and take a look here in a minute and see what's really on the inside of this thing. In case you're curious, this thing has been serviced by General Electric. I guess that's the tech number 47475. Anyway, yeah, somebody's been in it before. Do not plug into direct current. Hoo-ha. Alright, so here's inside this beast. And definitely Japanese manufacturing here. There's a Sanyo IC there for the radio. It's using IF cans. And it's got a 3-gang tuner on it, so it can't be all bad. Okay size power transformer, single-ended, 2200 microfarad at, what is that, 50 volts? Yeah, looks like 50 working volts there. You've got your TO220 push-pull. Let's see, what did I guess? About 470 microfarads on the output capacitors. Let's see what they actually are. Yep, 470. That's why the low frequency rolls off so fast. They don't want you eating up headroom. Here's your 8-track mechanism that screams Matsushita. And here's what's more interesting. They got this, I guess it is a 4-channel unit, because they've got a primitive decoder board back here. And it looked like it was meant to go in another machine because it's got a card slot on it, as you can see. So it was supposed to go into something else, and they hardwired this in. And then back here we've got another supply with a switching relay. Interesting one, I don't know what that is. And then here's your front panel with your tone controls. Come on, focus. Yeah, there's where your tone control and volume is. And that, pretty simple stuff. I mean, it's coming in from the rear here, and it goes to your input selector, which is that guy there. And then I guess all the magic of the loudness and everything is done on that board there with the sliders, because you can kind of see the little resistor and little tiny capacitors in the tone control network. So we'll need to look at that and see if that's even viable to make that work properly. This motor is frozen solid. I mean, rock solid. It's really stuck, and it's got that decomposing belt tar crap on it. If you get this anywhere, it's never coming out. I gotta go clean my finger off now. Alright, well anyway, yeah, even after alcohol and acetone, it stained my finger. That belt goo is evil. Anyway, here's your record oscillators probably in here. This is the circuit board that does all of the amplification for the tape head and whatnot, because you can record on this one. Not much else to this, but stuff in here is really buried. I don't know if this is going to be worth his time to mess with. That frozen motor I might be able to salvage, but is it really worth it? I don't think so. Unless you really love 8-tracks and you got a whole bunch of them, probably just leave it be. I worry about the hassle of getting the tone controls fixed. Oh, look at that. 2SA672. That is really a bad transistor. 2SA672, 2SC1344, 45, 2SC458. They're all in that Hitachi package that likes to die horribly. That's probably where our amplifier noise is coming from. And the radio sensitivity sucks. But there's really not a lot of electrolytic capacitors here. You've got all of these little tuned IF cans, which probably need to be redialed in. They're not all that precise. It's not narrow band. I don't expect stellar performance from this, but I expect better than 10,000 microvolt sensitivity. So I got to look at that too. So yeah, this is I'm going to submit an estimate to the guy and see really how far he wants to take it, because I could see spending hours of my life on this thing, and it still is never going to be anything more than a cool looking thing with mediocre performance. I think even you could do a total recap of this amplifier. We could pull this board out and we could get rid of the equalization for the speakers and just make it basic tone controls and a flat amp, but all for 8 watts a channel, and again, very mediocre performance. I don't think it's worth it. That's my opinion, but it's not my machine. So we're going to ask, and we're going to see what he wants to do. And if he wants to spend all the time and money to get this thing better, it's never going to be great. Much better options out there. But if you like it, it's a cool thing, you want to pursue it, fine. So, if you see more in this video series, it's because you approved the estimate. And if not, then this is where it ends. So, in any case, thanks for watching the video, guys. More stuff to come soon.